started with the 9 UN hazard classes and divisions. You can find those in your ERG. Printed out the just a quick cheat sheet here. We'll go through each class and kind of what the associated hazards are. There's one on there. This doesn't really apply to what we're doing, so you don't need to know about that. Okay, so the hazard class is going to be based on what is going to be the most dangerous chemical or physical property. Some of them have other associated properties or dangers, but we want to go with what's going to be the most severe. So we look at our classes. Class 1, explosives. 2 is gas. 3 is flammable or combustible liquids. 4 is flammable solids. Then we've got like the spontaneously combustible or dangerous when wet. Then class 5 is oxidizers. 6, toxic and infectious substances. 7 is radioactive. 8 is corrosive. And then 9 is the miscellaneous, like we couldn't classify them elsewhere. Then they're going to be further subdivided. So looking at class 1, explosives, you'll see on there you have 1.1, 1.2, 1.3, 1.4. And those give you like the special hazards with that. So if you look at page 51, actually 50 and 51, it kind of goes more into detail. So we've got a 1.1. What is that? Big boom. Okay, how about a 1.6?
Really big.
Yeah. No. Insensitive. 1.6 is extremely insensitive.
Really mean.
So, an example it gives is low vulnerability military weapons. One point two, what would be our hazard with that?
Like shrapnel or things flying.
So it's good to look at those and have an idea of what you're dealing with. So you would see 1.1, you're like, oh, yeah. So we're gonna be pretty concerned there. And with 1.3, okay, what do we need to be getting prepared for? Okay, good. Do you guys know what a binary explosive is? Okay, what it is, it's an explosive that has 2 components, and by themselves, each of those components are not explosive, but you put them together and then they become explosive. So here shows this area right here is designated specifically for those explosives. That might not be the full vehicle. So it's certain storage area. All right, so what are your hazards, primary hazards of an explosive? Without looking at the slide I just showed you, what do you think it will be? Think of an explosion, and what are you worried about?
Heat.
Wait, what did you say?
Heat.
Heat. Okay, so you got thermal. And
Oh.
what was it?
Like flying things.
Okay.
Flying hazards.
And so that would be what?
Okay.
Okay, yeah, it's mechanical. So fire and things. Another concern we have would be a blast pressure wave or a shock wave. And I think it's common sense that as it moves out, it kind of loses its strength and velocity. So the closer you are, the more damaging. And then it has a positive and a negative phase. I'm going to show you a video that I thought was pretty cool. I think it's about 5 minutes long.
Explosions can cause widespread destruction, not just from the initial blast, but also from the shock wave that follows. The shock wave is a powerful blast of air that emanates from the explosion and travels at supersonic speeds, pushing aside anything in its path. As the explosion occurs, it creates a rapidly expanding sphere of compressed air that moves outward from the center of the blast. The shock wave can travel through any medium, including air, water, and solid objects like buildings and walls. When the shock wave reaches an object, it applies a sudden pressure that can cause damage or destruction. Scientists measured the force of a shock wave in pounds per square inch psi. The higher the psi, the more destructive the shock wave can be. Explosions and their shock waves can cause serious injuries and fatalities, as well as extensive damage to property and infrastructure. Knowing how explosion shock waves work can help us better prepare for their potential impact and mitigate their effects.
Something they would show you, like, part of the negative pressure, so we have that positive pressure out, and then the negative pressure is like the decreasing pressure, and sometimes it sucks things back into it, so that's that negative pressure. Does it make sense? All right, so we know that the shrapnel and fragmentation can go quite a ways. I mean, we saw that in some of those explosions. And of course, that can cause injury or fatality. Seismic effect, you guys know what that is? Yeah, earthquakes are a type of seismic, so the vibration of the ground, and so it can mimic an earthquake. The Seahawks game. They had seismic activity just from the crowd cheering and stomping. All right, so here's one thing to note, the distance that the shockwave travels is dependent on the type, size of explosion, pretty common sense there, but also the type of soil that travels. You might see a fireball, the interaction of those combustible gases or flammable vapors. So you have that volume of that plastic, and then it will dissipate. And so we do have additional hazards, the chemical hazards. The explosive can also self-contaminate. You guys ever seen like dynamite as it degrades, starts building up almost like a crystal goop up on the outside, and then it makes a pretty good state. Had somebody drop some off here once. Up here. Yeah, if anybody tries to drop off hazardous materials, don't accept it.
Oh.
Okay, class 2 gases. So this is a product that would be in a gaseous state at normal temperatures and pressures. We have, what do we have? Non-flammable gas, flammable gas. Notice the difference in the colors there. Oxygen and an inhalation hazard. Okay, so it kind of says it there, but looking at it without the big label there. What's that? Pressure container. How about that cryogenic? So when we look at our divisions, you can look at page 53. 2.1 would be a flammable gas. Can you think of an example? Propane. Methane. How about a non-flammable gas? 2.2.
Carbon dioxide.
Yeah.
Would carbon dioxide be classified as a toxic gas, or would it just be non-toxic?
No, I'd have to look into that because how would it be toxic to us?
Because of the asphyxiant properties.
Are all cryogenics non-flammable?
I would say, I'll have to get back to.
There's
You-
definitely flammable cryogenics.
Is it?
I was looking at
Okay,
the
what,
book the other day.
does it, like, what's the temperature range on that? You know, did it say,
Everything.
yeah,
It's
pretty
ridiculous.
wide.
I looked through the book and there's a couple that were they were cryogenic and they were similar in properties to liquid nitrogen, but they
Okay.
were compound materials that were also flammable, and so you can have a fire with that.
Uh-huh.
Which then you've got a temperature ranging from -130, -150 to positive 800, 900 degrees.
Whew. It's quite a fluctuation.
Yeah.
How about a toxic gas? What is toxic?
Poisonous.
Can you think of any examples of that? Find it. Pretty common one. Okay, this slide, that's in your book on page 53. Able to get one. These are your potential hazards. Looks like we're kind of all over the board there. Now moving on, page 54. Flammable liquids and combustible liquids. These ignite and burn really easily. So what is something that we see almost daily?
Yes.
Gasoline. A lot of hazardous materials involve this class. As we talked about, some have other hazards, so some flammable liquids are also corrosive. And they're not further subdivided like we saw in Division 1 and Division 2. So pressurized or not pressurized? The liquid. The containers, what that is. Pressure. But we talked about there's some degree, so you can have that splash or spray. We have to be concerned about the hazardous vapors and the vapors that will burn if they're ignited. So what's our primary hazard?
Thermal.
These are further defined in our table 2.5. I'll give you guys a minute to kind of read through that. Okay, so looking at flammable and combustible, what is the big difference there?
The temperature.
So tell me about that.
So for flammable. Flash point. If adjustable, the flash point is above.
So flammable, flash point less than 140, and combustible flash point above 140 and below 200. These are hazards associated. Okay, what's class 4?
I have a question.
Yeah, go ahead.
So in the book, it says that a flammable material is intentionally heated and offered for transportation at or above its flash point in bulk packaging. Why is that?
Okay, let's see. Give me 1 second to read that. Okay, flammable solids. Really combust in the presence of the ignition source without outside changes to the density of pressure. Is spontaneously combustible. What is another term for that? Okay. Right. You don't need that external ignition source. Dangerous when wet. They come in contact with water, then they become flammable or give off the toxic gas. So I'm going to show you guys a video a little bit later about something that had a violent reaction with water. The firefighter put water on it, and it didn't go as they had planned. Here it is. I'll show you. It's just a quick video. Pull it up.
Some things are so reactive that as soon as they come into contact with air, they burst into flames. And I have two things here. Now, the first one is something that Chris prepared. It's a piece of filter paper, but we've coated it with phosphorus. And phosphorus is a very reactive element, so reactive that as soon as it comes into contact with air, it sets fire to itself. Well, at least that's the theory, as I hope it does. Right. Now, at the moment, because we can't have the white phosphorus in contact with air, we've filled this container here with a different gas called argon. one is incredibly unreactive. It doesn't react with anything at all, absolutely nothing. So the phosphorus is safe at the moment, but as soon as it comes into contact with the air, it should catch fire. So when I take the filter paper out and hold it up, hopefully you'll see a reaction. Let me just have the lights down a little bit, please. There we are. So as soon as it came into contact with the air, it burst into flames. Good. So that was phosphorus reacting with air. And here's the chemical equation for this. We have phosphorus combining with the oxygen from the air to form the various phosphorus oxides that we formed here, but again, releasing energy in the form of light, heat. Okay, well, we have here another substance that's very, very reactive. Thank you.
Oh, we didn't get to find out what it was. All right, so some of our potential hazards for that, the chemical energy, the mechanical, could be corrosive, could be toxic. Have your thermal hazards, fires, molten substances, explosions, chemical hazards and burns. You might have the mechanical effects from a levy. You guys know what a levy is?
Boiling liquid. Expanding. Vapor explosion.
Yep, exactly. So I'm gonna show you a couple of videos and it shows how that happens.
In the transport of dangerous goods, recognized by most drivers as a major hazard. But few may be aware of the potentially devastating effects of a levy. Boiling liquid expanding vapor explosions have massive destructive force, likely to cause extensive damage over a wide area. Levies occur when the flammable liquid or gas in a tank is exposed to excess heat. In our industry, the heat generated by a fire on or near a vehicle may be sufficient to cause a levy. The flames heat the liquid in the tank and it starts to boil. This pressurizes the tank, which causes the relief valve to open. As more of the product boils off, the liquid level drops. Although the liquid in the tank absorbs some of the heat from the fire, in the vapor section, the heat quickly starts to weaken the metal. The vapor escaping from the relief valve could also ignite. If the flames impinge on the tank, this further increases the heat being generated and hastens the weakening of the metal. Eventually, the pressure will cause the weakened metal to rupture, and as the gas is released, it ignites, causing a massive fireball. To anyone in the immediate vicinity, the effect is likely to be fatal. But even the radiant heat generated in the blast can cause severe burns and start fires hundreds of meters away. Bits of tank metal and other projectiles can travel for miles. In the event of fire, tanks containing highly flammable liquids or gases are sprayed with water to cool the tank of its contents. These pictures show fire auxiliaries at ConocoPhillips Humber Refinery practicing dealing with fires around fixed tanks and vessels. They're not only cooling the vessel, but trying to stop the flaming product escaping from the pressure relief valve, impinging on the tank. Because of the risk posed by fire, many loading and unloading bays, particularly those for liquefied flammable gases, have drencher systems in place. You should also be aware that gas cylinders can also levy. The explosion of fireball may be much smaller, but the effect of dozens of mini levies can still be devastating. Levy is a real danger to all those involved in the transport of flammable liquids or gases. It's therefore clear that minimizing the risk of fire is a critical role for all drivers.
Okay, so what would be a danger with the levy? Okay,
Mechanical,
the mechanical, so the shrapnel, what else?
thermal.
Thermal? Good. I talked to my friend Google. And they said the reason it would be heated above its flash point is things that need to be at a higher temperature to overcome their viscosity, so it's like easier to apply. So they talk about like asphalt or certain oils and stuff, so that's what that is. So thank you for asking that question, because that wasn't anything I'd ever really thought. Here is, this one's just a quick one. Impressive, huh? I love seeing things blow up and catch on fire. I think if you're a witness to that on scene, it might cause you to. All right, class 5. Oxidizing substances and organic peroxides. These are materials that readily give off oxygen or oxidizing substances. These, of course, would they'll support combustion. And so you combine those with a fuel, they might continue to burn. There is another acronym here, so the MSST, the maximum safe storage temperature. They need to be transported below that, and then if they get above that, then we're gonna start to have problems. And so the SABT is that self-accelerating decomposition temperature. I'll show you another quick video here. It kind of talks about this was a little bit longer than I got it. Oh no, this one might be included. I'm sorry.
Class 5 is made up of 2 divisions: oxidizing substances and organic peroxides. Division 5.1 contains substances that, although not combustible themselves, are able to give off oxygen when subjected to heat. This oxygen is then available to stimulate combustion of other substances. Examples of Division 5.1 include granular pool cleaning chemicals and ammonium nitrate fertilizer. Division 5.2 are also strong oxidizers, but many are thermally unstable, some even at normal temperature. These substances are subject to explosive decomposition. They are sensitive to sudden shock, impact, or friction. They can react violently with other substances. They may explode or burn rapidly, and can attack the skin and eyes, capable of causing corneal damage. Examples of Division 5.2 include methyl ethyl ketone peroxide, or MEKP. This is a catalyst used in fiberglassing. Dicumyl peroxide, which is used as a cross-linking agent in the rubber and plastics industry. Dibenzoyl peroxide, which is primarily used in the manufacture of polymers like expandable polystyrene, but can also be used in acne treatment. And also acetone peroxide, which can be used as a flour bleaching agent. However, it is also an ingredient in some explosives. On 7th of July 2005 in London, 4 bombs were detonated, 3 in quick succession aboard underground trains, and later the 4th on a double-decker bus. These bombs were homemade, manufactured using acetone peroxide.
So, note here. Evacuate the area if the ambient temperature is rising. Because once we get to that, the SADT, it's gonna be a problem. Here is another video. This was after an incident, and so.
These materials have to be maintained cold. If they start to warm up, they become unstable and they will decompose. When they decompose, they generate heat. And when they generate heat, there's a possibility of fire and possible explosion.
What you are seeing are containers of one kind of organic peroxide polymerization initiator, a peroxide dicarbonate. What started them on their way to violent decomposition was exposure to elevated temperatures. This particular product must be stored below 0 degrees Fahrenheit. These containers were not. They were, in fact, allowed to reach the self-accelerating decomposition temperature, or SADT.
We do have 9 containers. These materials are stored in these box containers like you see on over the road storage containers. One of those containers has been involved and the product in that container has started to degrade. That happened early this morning. We fully expect that the other 8 containers will do the same thing. Water is still in our facility and preventing us from accessing the facility. And we believe at this point that the safest thing to do is to allow the other 8 containers, product in those to degrade and burn.
What are the potential hazards for the class 5?
It's much.
So, what are we thinking?
Thermal.
Thermal, good,
Mechanical,
good.
mechanical will get exposed.
What else?
Chemical.
Asphyxiation? Or explosive reactions. All right, class 6. I was telling you guys that we had to memorize these, so I have like mine, as I learned by association, so that's 6. That's how I remember that. So poisons, poison inhalation hazards, infectious substances. Very toxic to humans, so they could be microorganisms, toxins that can cause severe illness or fatality. So a little asterisk here, poison or poisonous can also be interchanged with toxic. Okay, just the wording here. Illness, injury, or death when inhaled, ingested, or absorbed. So don't inhale, ingest, or absorb them. And just know that they can travel a great distance. So generally speaking, the further away from a hazardous material, the safer we are. Yeah. Here it talks about, the infectious materials typically shipped in a small container. So they don't have a placard, but they're gonna have a label. We'll talk a little bit more about labels, here coming up in the next few slides. Biohazard label, you guys familiar with the biohazard label? If you look at page 61, there's a picture, but we probably see that, and it's not a lot of places around here. Always the potential to cause disease in humans or animals. Where might you find infectious materials? Here. Good housing here. Hospitals, clinics, hotels. Okay. Our primary hazards would be toxicity, which is kind of in its name. Inhalation causes disease, but you do have potential for chemical exposure. If we look at table 2.8. I'm giving you guys a little bit. Look through it. So would you think that the poison or PG1 would be better or worse than PG3?
Worse.
That's correct. The 1 is great danger, 2 is medium, and 3 is minor. Okay, here it clearly says it's an inhalation hazard. Infectious substance, biohazard. Okay, again, don't inhale or come in contact with plastics. All right, we're moving into class 7, which is radioactive. You just familiar with the trifoil symbol there? They got like a lot of like superhero stuff. You see that? Who's one that's like radioactive? Hulk. Hulk? Yeah. Okay. Oh, nice. The Hulk documentary. Yeah. Okay, so can you see, smell, or taste radiation?
No.
No. You have to have special monitoring or detection equipment. What are the primary hazards, do you think, with radioactive materials?
Etiological and biological.
Radiation.
Radiation burns, cancer, illness. Are you familiar with the Chernobyl incident? It was a nuclear facility that had a meltdown and killed a lot of people. So we had the immediate, like the acute, so killed a bunch of people, but also a lot of people became very sick, cancers and other. I'm not gonna pull it up, but on your own time you can look it up.
I just wanted to throw in, because I've done a lot of research into radiological stuff. There is a YouTube series called Half-Life Histories by a guy named Kyle Hill, and it's a really, really good series. And they have the Chernobyl disaster on there. I think he's a mechanical engineer or a civil engineer.
Okay.
But he does not full length, but like good length documentaries that detail, what happened, how it happened, and the science behind it in a dumbed down way that's easy to understand. So
Maybe if we have time, we can check that out later. So it's Half-Life Histories?
Half-Life Histories, yeah.
Okay, cool.
On the numbers. The 1, 2, and 3.
We can go further into it on page 62. You see the difference, you got radioactive 1, radioactive 2, 3. What happens if you see an empty label?
It's been empty.
It's still radioactive.
What's station? So, right underneath the radioactive 3, it's visible.
Mhm.
It says materials capable of undergoing fission.
Mhm. So you have to break it up with that. We're gonna go a lot further in depth into radiation in operations. So, yeah, we'll talk about how all of that works and on the different levels and protection. So right now, we're through the awareness, you just have an idea of what each of these labels mean.
Gotcha.
Okay. Corrosive. And for me, kind of a dumb association, but I always thought like you can make it 8 right here. Class 8 is corrosive. So these are bad. If you get them on your skin, it will eat right through it. And can also damage metals. Corrosive is corrosive, it doesn't get broken down further. So here are some examples here. Battery fluid, battery acid, soda lime, sulfuric acid, hydrochloric acid, hydroxide. Isn't the soda lime what like dissolves bodies? Yeah. I think that's what I've never done it, so but you see like those murder shows. Gross.
I believe you.
Yeah. All right, so we have a lot of hazards that can be associated with class 8. Be toxic, flammable, reactive, explosive, mechanical, oxidizers, thermal, chemical. All right, so leave this, we're wrapping it up here, class 9. Stuff that wasn't gonna be classified elsewhere. Lots of different things that can go into this, the PCBs, like lithium ion batteries. Marine pollutants are included in this. Look at later on. Different hazardous wastes. Oh, here's a picture of that. That's the marine pollutant. That's a dead fish. Primary hazards, thermal, chemical. I also know that sometimes things are not marked properly. And of course, we have people that don't follow the laws, because they're not going to be mindful of putting a placard on their truck or vehicle. Things without permits. What are the 9 hazard classes? See if you can remember without looking at your thing. Okay, what's number 1?
Explosive.
Okay. Number 2,
Gas.
3,
Flammable.
flammable, yeah, liquids. Okay, and how about 4?
Petrol.
Yeah, so flammable solids, which includes spontaneously combustible and dangerous when wet. Okay, what's 5? Oxidizer? Yeah, I remember that one because Hawaii 5.0. That's how I remembered it. Okay, what's 6?
Poisoned.
Yeah, poison or toxic makes you sick. Okay, what's 7?
Radiation.
Radioactive. Okay. Number 8. And number 9.
Miscellaneous.
Awesome. Okay. What are we most likely to see here?
Radioactive.
Flammable,
I'm thinking of Hanford, sorry.
Flammable.
flammable fluids.
Yeah, I would say so. Hanford's pretty well controlled.
My brain just like curious, HazMat goes to Hanford.
Yeah. All right, let's take 10 minutes. Be back at 10. Transportation placards marking. What is DOT? What do they oversee? All right, so there's some consistency in the placards. So these are all the things that are required of them. Have to be 9.84 inches. The color, the number, identify the hazard class. And it has to be identified by the division number it's printed name. Okay. So breaking it down, here we've got a diamond shape. And how big is it? Okay, and then we have our 4-digit identification number, our hazard class designation. So it's a 1090. Where are you going to look for it?
The yellow.
The yellow pages, yeah.
Acetone.
Okay. So we know what it's. What's a 3?
Flammable liquids.
And what color is that? Well, I guess it kind of looks, it's after, right? So what are the different colors we can have?
Orange, yellow, red, white, blue, green.
Where you can see green? Yeah, where you can see green.
Non-flammable.
Non-flammable. Okay. You can also have a symbol there. So explosive, you can kind of see the shrapnel there, oxidizer, radioactive, flammable, non-flammable. Corrosive, and then you guys have probably seen these before. When you look at them, just you kind of there's rainbow right to what it is.
It did this morning.
Okay.
So it's gasoline.
So you're gonna use the DOT placards, full packages, rail cards, cargo paint, purple paints, load devices, certain non-bolt. But keep in mind, as we talked about, you might encounter some things that are improperly marked, unmarked, or illegal. This is a worldwide. We'll have consistency. So what is like a 1090 here should be 1090 in Canada and 90 in Europe. If there's not a UN number available, then we're going to use the NA number. I think there's only like half a dozen, maybe 10 that don't have a UN number. Those are going to be an 8 or a 9. So flip to your the end of your yellow pages. So just a handful there. But we still know what to do with it. So we take 9260. What are you gonna do? You see the placard says 9260. What do you do next?
Go to the guide.
Okay, what number is that? 169? Sure. So what if we have a fire explosion?
It violently reacts with water.
Okay. What if it's,
Like combustible materials.
yeah, what if it crashed into a lumber yard?
It will ignite if it comes.
It's a pet thing. What happens if we have a spill or a leak and no fire?
Don't stop it, don't touch it.
No, I tend to stop the leak. It is either it or it.
Dry sand to contain raw materials.
Use those diapers too. I call them diapers. It's that weird white pad or gray pad that you put over the top with another amount, or does it have sand
I
or?
would seek expert consultation.
I like your.
All right. Sometimes we'll see trucks that are or different types of hazards transported together. So which placard would we see? What placard would be required if we had maybe some? I think what we have. Combustible, solid, and miscellaneous. Yeah, oh, good question. Just to note, an identification number displayed on a white display is not considered to be a placard. So many things that go into this. All right, so we're starting to get familiar with the ERG. If you want to read all of the stuff, I did 49 CFR 172-1, a little light reading for you. USDOT issues the North American numbers. Those are going to be the same as UN whenever possible. Like we talked about, if a UN is not available, you know, either be an 8 or a 9. All right. So you roll up and you're responding to an incident involving someone that's rolled over and you see a placard on it. What are you gonna look for?
Do you? Or I guess you're starting off, you're gonna look at the
Okay, color's gonna be the easiest to recognize probably. How about what else you gonna know? Number, the hazard class. You're looking at a 2, you're looking at a 4, 3, okay. And then the UN or identification number. And then we'll do different. Whoa. Just to note, you might have a group of chemicals. What was the one we looked at yesterday? It was, we looked up a number and it could have been a few different things. Do you guys remember what that one was?
The diesel,
Yeah.
can't think of the number.
Is it 1993?
1993 is diesel.
Oh, it's right in here. So these, okay. So we look at it. Well, it's right, it could be the tree or weed killer. Diesel, flammable liquid, fuel oil. They just group them together. All right, now moving on to page 69. So we have an orange panel here. And we can have a 2 or 3 digit code required, that's required under European and South America. And then this is the UN number. So what is this number? What's 6?
Toxic.
Okay. It's double. So what does that mean?
Double.
It's we talk about potentiating, right? Yes, really. So the double number would be. I think of it as like twice as bad. It's more worse. Now what if there's an X in front of it?
Reacted with water.
This looks similar to what we see in our hazard classes. Yeah. So if we see X with 4 and a 0.
It would be flammability of solids or self-heating solid.
And then what's the X?
Reacting with water.
If this is okay, so here's double 8. So what does that mean? Double that. More battery.
So that just basically means like the number on the placard.
Yeah, there's
It's double, it's worse.
yeah. And then if it's just like that, then you'll have a 0. Okay, now if we see a 9, what's that?
So the miscellaneous.
Oh, I'm sorry, a 9 again. Yes, I should have clarified. I didn't ask that very well. So you have like an 8, 9.
Be corrosive and violently reactable.
Spontaneous violent reaction. Okay, so we have a placard. What are we looking for?
Color.
Color?
Number.
Number? Which number?
The identification.
Okay,
40.
the 4-digit identification number. What else?
Division number.
Division number. Okay, and what else?
The little pictogram illustration.
Yeah, exactly. With the label.
That's like a placard, but not.
Yeah, it's like a placard, but it's not. It's just the same but different. Okay, so that's gonna go on the package being shipped, so not on the actual transportation, outside of the transportation, it's on the package. Same shape, but smaller. And again, their specifications. So we get these random numbers, 3.9, but in metric, it's 100 millimeters. Oh, these smaller variations of that. So to sum it up, placed on hazmat packages, whereas placards are placed on hazmat transportation vehicles. Let's read this for me. I go and read that a lot. I have to send Chief a message.
There are some unique labels that have no equivalent placards. Most labels for the 9 hazard classes and subdivisions are essentially the same as the placarding counterparts. A few exceptions. such as class 7 radioactive and class 6 infectious substance labels, which always contain text. Cargo aircraft only label is not associated with a particular hazard, is used to indicate materials that cannot be transported on passenger aircraft.
Okay. So here, it talked about, if you have more than one hazard class. Okay, so this is toxic and it's a flammable liquid, so, that's the primary and then that's secondary. Okay, how are, labels different than placards?
They're on the package, not on the transportation.
Okay. And what's different about their characteristics?
Labels
Yeah, so you know the answer, say it with the,
Smaller.
they're smaller, yes. Okay, how are you guys doing?
I learned something.
We're learning. All right. I don't know about you guys, my brain's starting to hurt, and I'm not even learning that. Okay, so then we have, further, we've got markings. So these might be things that are additional safety precautions, if there is a spill or accident, to help prevent exposures. These are gonna be required on the outer packaging of milk bulk. They sometimes the styles vary, but they need to be sharply contrasting and they can't be covered. So they may have the descriptive name, they might have the identification number, might have the waiter's specification for any instructions or precautions. So here's an example of one. All right, so this is sulfuryl fluoride. Look that one up for me. Where are we gonna go?
The blue.
Blue pages.
Which one?
A sulfuryl chloride.
Hey, what do you guys find out?
Toxic.
Maybe fatal if But maybe fatal if inhaled or absorbed through your skin.
Okay.
So toxic has it in things, so you have to go to the green highlighted material for the
Oh,
goods.
nice.
It also says contact with gas or liquefied gas may cause burns, severe injury, and or frostbite. So I don't.
That's not good. Okay, we have a small spill. What are we gonna do?
isolate 100 feet in all directions.
What about a large spill?
1,250 feet.
How far is it? No? Pretty far. Yeah. Anybody run track?
There's one lap is like 400 feet.
It's about a quarter of a mile. So a little bit of a ways. All right. Okay, so you guys are getting more comfortable with the ERD? Don't worry, we'll get more practice. All right, so anything that poisons by inhalation. You can see with the inhalation hazard. Hot, you seen that before? This would be a picture, it says hot. So molten sulfur, roofing, road tower, molten aluminum. You guys ever like, who's bought a computer recently? Okay, did you see the lithium ion working on it? I've seen more and more stuff about the lithium ion batteries. And they're becoming a problem. For firefighters. Marine pollution. You guys are familiar with the biohazard marking? So we've got regulated medical waste, you can see it on there, waste or reusable material. Known to contain an infectious substance. Just to know, regulated medical waste may be defined differently by state and federal agencies. Let's look for a good example of this for you guys. I didn't see one really. But it will be labeled sour fruit oil merchant. You can read those papers that prevent an inhalation hazard. Okay, give me an example of a hazard marking you might find it on a package. Okay. What else?
Fumigating.
What's that?
Fumigating.
Okay. What do we see on that one?
And then the poison.
And hot. Okay. Yeah, go ahead.
I should say a biohazard.
Yeah.
label.
Good. Okay. We have pipelines here. Might be a problem for us. That's been a problem. All right, what gets transported through pipelines? Natural gas. That's the most common one. We see that a lot around here. What else?
Liquids used in combustion processes.
Pipelines be like sewage. Or like water, more like pressurized. Seems. You're in the pipeline. What happens when we have somebody strikes a pipeline? What are we gonna do?
Call utility companies.
Call them.
Call utilities, yeah. And probably evacuate. Okay, so how do we know what is in the pipeline? Those markers. Yeah. Okay, what's in this one? Can you guys see it?
Petroleum.
Petroleum. Okay, can you see that one? If you go behind station 430, there's actually a pipeline marker there. I think within like 3 feet. Like this is where we think the pipeline is, but there's a margin of error. So that's what gets people in trouble sometimes. Okay, so we have here on the marker, can we know what it is? We know who the operator is. Who's the operator? Chevron. Okay, and the 24-hour number. Okay, who do we call? Not Ghostbusters. Yeah, that's probably going to be on your test, whether it's awareness or ops. I don't remember. But yeah, you guys will sit down and you're like, wait, I don't get it. This is really easy. So you look for okay, what's the product? Petroleum. Okay, who's the operator? Who do you call? Okay, there we go. Yeah, we see them in residential neighborhoods. They're all over. surprised we might have
That's the number.
So there's, in your book, talks about, I mean, you can Google any pipeline emergency. They're all over, and they have the potential to be extremely catastrophic. There's one that's cited here, the Merrimack Valley gas disaster. What happened, they had, like pipeline, I can't remember why they did it, but they took off, like, part of the pipeline, capped it off. But immediately they started seeing like pressure, like high pressures in their system. And then they were having some explosions, and all over like the city, there were like fires. And so can you imagine what that would do to your 911 system? I mean, that's gonna take everybody out. And it took a while before, so they shut it down, then they went to each house and that had the gas and shut it down. You can watch, there's stories on it if you want to check it out. But we've had them out here. Fortunately, our stuff has been contained. Have you responded to some of those?
Yeah, the one by 4:30.
Oh, that's right, that was a bigger one, because that was like a 4-inch line, right?
Yeah,
So that was like a feeder. So you guys were out there for a while,
yeah,
and was it blowing like the dirt and stuff up with it?
yeah, not too bad though, because it had the green stuff on it, so packed on the, can't think of what that is.
Okay. Yeah. And then I'm sure you had, was it CNG, was there Caspian natural gas? Yeah. Yeah, we've had, I mostly just responded to like the smaller lines going into the home, so you know, they come like big and then it breaks off into different sizes. So. All right. You guys still doing good? Now we're gonna shift gears from transportation to non-transportation. We still want to know what's what we're dealing with or how to recognize it. So you have labels, safety signs. So things that indicate there's hazmat at the facility or in the facility pipelines or other containers. So these are different things that you'll see. You guys have probably seen these, but maybe haven't paid close attention. Do any of these look familiar to you?
Yes.
NFPA 704 system. Go to okay, here we go. 76 probably. This we're gonna see on like a fixed facility. We're gonna see it maybe on you can see it on a propane tank, you can see it on like a 55-gallon drum. Things that aren't, I guess would say that aren't used for transportation. So we look at, there's 4 quadrants in it. And they're color coded, they're uniform, so they will always be the same when they have this the 704 hazard identification. Blue, health hazard, red is the flammability, yellow is the instability, and then the special hazards get put in the white, which is on the bottom. And it's a rating of 0 to 4, 0 being very minimal and 4 being a severe hazard. So we look here, what is this? So you've got a 4 here, and in that red box, so what do you think?
Highly flammable.
Yeah, good. And so the yellow is your stability. What would a 0 indicate to you?
Yep.
So we're not really too concerned about the stability of that. Okay, then blue is the health. What's a 2?
It's not bad, but it's not good.
Yeah. And then this is where we're gonna see those special hazards. So oxidizing, simple asphyxiant, or the reacts violently with water. So that's gonna be the W with the cross through. If there's more than one special hazard, you'll see the multiple symbols. Just note if you're outside the US, it might be a little bit different. All right, so in the NFPA 704, what is blue?
Health.
Health, what's red?
Firewood.
Fire, flammable. What's the yellow? And then what's the white? Special hazard. All right. The globally harmonized system is GHS. It's a worldwide initiative to have some standardization. Of the way we classify our chemicals. Based on their health, physical and environmental hazards. We want things that, we want consistency and compatibility in our labels, in our SBS, the safety data sheets, and other hazard communications. That way, no matter where it comes from, no matter where it goes, where you are, you'll have some consistency. And you'll be able to understand what the hazards are. Make sense? So what is it? GHS is,
Globally harmonized systems.
I like harmony. It's always. All right. Hazard communication standard. These are the pictograms. And that is in your book on page 78. So when you look at these and you can immediately recognize what the hazard is. Okay, this one's pretty easy. Look at that one. What's that? Gas cylinder. Here, what's this one? What's this one? Dead fish, yeah. Environment. And acute toxicity. Then over here, health hazard. Okay, what's the purpose of the GHS?
To standardize the labels and placards and everything.
Yeah, well, right, OSHA does require that your employer identifies, classifies, and communicates those hazards to their employees and train individuals to recognize those hazards. They must be correctly labeled, tagged or marked. Can't have like a spray bottle that's not marked or properly marked. You can't pour like Windex into a bleach container or vice versa. So just to know it doesn't have a specific system required by the individual employers. Hazardous materials identification system, of course, we have another acronym. So this looks pretty similar to the 704. So I look at the health here. Relatively not bad for you. How about, is it flammable?
Yes.
Yeah, pretty flammable. And is it stable?
Yep.
We can include in our pre-incident surveys when we're going in, what kind of hazardous materials they have. Sometimes when we go in, we'll ask to see their SDS. So it used to be that SDSs were, when they were called MSDSs, which the material safety data sheets, they were kept in the book, but now you can keep them electronically. So it's a little bit harder for us to look at those, but kind of gives you an idea. I was telling you guys about going down to that fire at the service master, and he just brought me a book. These are the chemicals we have in there, so. But there was a lot to look through, so. All right, the chemical abstract number. Yeah, there's a lot of stuff and a lot of acronyms. You'll see those on your SDS. I printed out like a way to read an SDS. I'll give that to you guys. Military markings, we're not going to see those too much around here. Where are some places you would see them?
Forgot to call out to mutual aid on Hanford.
You might see what there.
Roadways,
What roadway?
they transport down that.
Yeah, okay.
Military base.
Military base.
Over in Tacoma.
Yeah.
What about for Yakima?
Yakima training.
You recognize any of these?
We didn't really have many of those because we were mostly a training base, so. Yeah, but there were a few.
What do you recall any of the ones you did see?
There's a lot of explosive ones, yeah.
Yeah. I think they picked that area because nobody cares if you blow stuff up. Kind of like out here in Tri-City, nobody wants to live there because. The nuclear reactor. Okay, so, here we've got, just be aware of these, I don't know if were these on, have you guys seen these on your awareness?
They gave it as a little picture.
Okay,
Would they sort of
That's right,
attached it
they
to or?
have it, so, before they did, you just had to memorize them. So we got mass explosion, we got fragment hazards, you can think about that, these are all going out. Mass fire, and then moderate fire, no blast. Then these are, some of your PPE. I like these: red, you're dead; yellow, you're mellow; white is white. Reading ingredients. That's supposed to be water. We're applying water. And also some chemical hazards. When you think about what the military might encounter, we've got nerve agents, B nerve agents, incapacitating nerve agents, mustard agent or blister agent, Lewisite blister agent. If you want to see something gross, look that up. Who do you think regulates the pesticides?
Department of Agriculture.
Where's it at?
The DOD.
EPA Environmental Protection.
I already.
I had it, it was there.
Okay. And then on your pesticide label, you're gonna see the hazard statement. So the hazard statement. So here are some examples. Pictogram. Precautionary statement. Number product identifier, your signal words like such as danger, warning, and then who the supplier is. We'll get more into that, looking at the SDS, because that kind of outlines all of that. So here we're looking at the pesticide. You've got your product identifier. So what is this? So here for commercial use only, ingredients. Okay, so now we know, can't really see it. That tells us what it is. You got your EPA registration number. Your hazard, what's your hazard statement?
Caution.
For each of children.
Okay. You're on the right path. So your signal word is caution. Pictogram.
Toxic.
And then here, what you do is you need to provide first aid. So here it just kind of outlines everything you're supposed to do. So on your skin, you take off your clothes. Well, take the clothes off the person who's been exposed. If inhaled, get fresh air. So it tells you all those things. And then it tells you who the supplier is. So here it's OHP, the emergency number. And then here to there's no specific antidote available. Treat your symptoms. Okay, just know the caution there. Inert ingredients, not active pesticides, but can be highly hazardous materials. Okay, what's precautionary statement?
Not the like this single word.
Tells us what to do.
So they address prevention, response, storage, and disposal. All right, here's another one that we might see. BCB, that's something that I think is, we're becoming more and more aware of it. The EPA, what do they oversee?
Oh.
Health and environment. Do they require anything that has basic fees? We know that those may cause cancer. We're getting closer. I don't know if we're gonna make it through without another breakthrough. Okay, now we're moving on to page 84. Yeah, this is a lot, isn't it? There's a lot that goes into having that. There's a lot of different agencies involved. Globally, a lot of different things. So, did these look familiar? So here is an international organization for standardization, but it doesn't, it's not iOS, it's ISO, and that's just like a translation thing. So without looking at the word, what is this one? Okay, what's this one? What's this one? This one? This one?
Radioactive.
Yeah, it's not flammable. Oh, they tricked you there. And the book is correct, but.
Oh man, guys, this is flammable.
Okay,
I
how's
looked
this?
I was like, huh?
Oxidizer. And then this is an irritant. Can you think of anything, special markings or labels? This here and here?
So we see the biohazard.
Biohazard, yeah, especially around here. What about what we have, what else we have in our, aside from the residential, what are some of our industries here?
Welding.
Welding, okay. Okay.
Yeah, pesticide.
Pesticide, yeah. What else?
Oxidizers. Some corrosives too. And that on plastic levels.
Be back in 10 minutes, which will put us at 11 o'clock. Some of the ways we can get hazard information. So thinking about a fixed facility, where might we be able to get information about the hazardous materials?
In a fixed facility, maybe your free incident plan.
Safety data sheet.
Safety data sheets, good. Where else?
Yes,
Manufacturers. The
Ask them.
I was gonna say like the administration office, or yes. I was kind of just thinking like this warehouse that's got all these power lines and crap like that. You go into where they all meet, actually work, and be like, hey, what's going on here?
Yeah, okay. All right, what else? What else can give us clues about what's happening inside?
Richie.
It's a good resort, yeah.
Inventory records.
Inventory records, yeah, good.
The label and marketing on the website.
Good. Labels, markings. Other facility documents that we have, should be receiving papers, what's going out, what's coming in. Okay, how about for transportation incidents? We want to know what we're dealing with, so what are we looking at?
Placards.
Placards, good. And from the placards, what else might we? What else?
the driver.
The driver, yeah.
Yes.
That's good. How about looking at the shape of the vehicle? We've got our ERD, shipping papers, other types of labels. And in a facility, you're required to keep a chemical inventory list. All your hazardous materials, hopefully they keep it updated. Risk management, hazardous communication plans. For the local emergency planning committee. Okay, here we are in Benton County. Got our local emergency planning committee. And we can go in here, it gives us all sorts of information. Here we got, Appendix J, petroleum crude oil response. Kind of an overview. Evacuation routes. Here are considered tier 2 facility and their contents.
How does it classify different tiers of facilities?
Based on risk. These are all different agencies that can support what their roles are. Here we go with the incident command agency. Here we go. Talks about what we do if we shelter in place. We'll talk about that here in a few minutes. We have to evacuate. Different things here. Let me get down towards the bottom here. But these are just the different expectations at each level. If you guys want to read it, you can. You know, in here it talks about certain. Talk about our mutual aid. Not a number of them. Here are area spill resources. So BNSF has a boom. The things that we should complete. Home. We go. Go right to our local emergency planning. A 60-page document. Different things. Okay. Move it up. All right, so we have a transportation incident. We need some information. Where we're going to get them.
ERG.
Driver. So we're going to first ask the driver. Driver's not available. We need the air. They're called air bills. They're going to be in the cockpit. Pilot is responsible for that. This is on page 85. Highway hours, the bill of lading is Bill is a truck driver. I remember it. This could be in the cab. Or with the driver. I mean, obviously, these are where we expect them to be. Sometimes things move. The rail is gonna be a train list or a consist. We expect that to be either in the engine or the caboose. The conductor is responsible for it. In the waterways, it's gonna be an intercargo manifest. It'll either be in the bridge or the pilot house, and it'll be the master is responsible. Shipping papers have a standard way that they are supposed to provide information. Think about I ship, the identification number, shipping name, hazard class, and so give you some clues. Your hazard associated. So if you can't locate the waybill or the consist, contact. So in that document I showed you guys through the county, the local emergency, I think they have these contact information. But fortunately, we have these. We can look it up real quick. Sometimes we'll dispatch provides that stuff for us. Can you contact UNICEF or like this in touch? I don't know if anybody uses fax anymore. There's an option. All right. Incident involving a truck. We're gonna go. Driver. Yeah.
Okay.
What's it called? Okay. How about on an airplane?
Cockpit.
Cockpit. Pilot. And what's it called?
Airplane.
How about on a rail car? Where do we go?
The engine.
Engine or caboose, okay? Or we can ask who?
The conductor.
Okay. Don't have access to any of those three. Who do we contact?
UNICEF.
The rail, yeah, it might not be BNSF, whoever it is. On rail cars, they have a reporting mark, it's a serial number. Identify the car. Of every element. Think of it like, what do you call that, the VIN number, so. Identifies the car, the owner, the owned by the railroad company. We have another acronym. Standard transportation commodity codes. Hazardous material response codes. Oops, sorry guys. All right, now, get into these, can be very valuable. We've got some mobile apps. I have a bunch. I have like a folder, I call it like fire stuff. And you can get, like, I've got the ERG on here. It makes it super easy just to flip through it. Might have, anybody have any of those downloaded on their phone? What do you like to use?
The ERG.
Ask Rail, I don't have that one. It's really not something that I really needed. Of course, if we had, and maybe in Pasco, where they have a lot more rail traffic, and they've got some loading and unloading, maybe something they would want there. Let's see what else. Wider. I just breezed through it. So on a rail car, you have your 7-digit code. Got a 48 is gonna be hazardous waste, and 49 is gonna be hazardous material. Just know it doesn't tell you everything, but it's a pretty good guide. Safety data sheets, this gives everything that you will need to know on an SDS. You guys will probably have to read an SDS for your test. Like I said, all of these are now electronic. It's nice because you're like, okay, I got whatever the chemical is, I can look it up here. And it's right there. But somebody hands you SDS, let's go through these.
Thank you.
All right, so I'm looking at your safety data sheet. Okay, we want to know, what is it? What are we working with? Resources wiser. Wireless information system for emergency responders. You go there, you can get all sorts of information. Chemical identifications, characteristics, health hazard, containment. Great resource for us. All right, sensory clues. What kind of sensory clues can you use to identify identify the presence of hazardous materials? Your eyeballs sees it. Okay.
Hearing,
Hear it? Okay, what kind of things are you gonna hear? Okay, explosions. What else?
people,
Is he? Yeah. What did you say?
like people, they need rescued, they're not conscious.
I got. The hazmat on me. Okay. What else?
Sometimes, not preferably, but you can smell the hazard. So you say.
Yeah, we're gonna try not to.
Yeah.
Preferably touch it. So we don't wanna smell it, we don't wanna taste it. And, but,
You smell like propane, you know something.
yeah, so if you smell it, what does that mean?
You're in.
You've been exposed, yeah. But some of your victims might tell you, I smelled almonds. I tasted whatever it is. Sight and hearing can be used with a degree of safety. Stay back, because what distance is our friend? Yeah, you did the thumb. And I cover the incident with my thumb. Okay, so what are some ways, what do we see? What are some ways that we can with our sight? We know there's a hazmat.
There's vapor in the air or on the ground, you know, something like, if it's a spill, if like liquid. You know, you can see that.
What about victims down? Birds. We said we don't want to smell it because that means we've been exposed, but if you smell like a pungent odor. Unusual business, like you can hear that the hissing or a whistle or something under pressure. We can also use our site to look at placards, container shapes. Know that if it's on fire, smoking, your potential for exposure is increased. Talk about dead animals. It's like all the trees are gone off of a tree and all the trees are, all the leaves are off of a tree in the middle of summer. They're discolored. Dirt blowing from a hole in the ground, what do you think?
Pipeline.
Hmm? What if it's summer and you see frozen ground?
Yeah.
Right.
Okay. Pulling up liquid. Oh, you've seen this, yeah, the bubbling or rainbow sheen on the surface of water. Yep, that's cool. How about a container that's got like a weird, that's not what it's supposed to be shaped like. Okay. Person's collapse, vomiting, watering eyes, coughing, respiratory distress. All things that can indicate hazardous material. Okay. We might see these anyway, but we have alarms, people yelling. Accidents. Hissing, whistling, roaring sound. That's a bigger link. Front eggs. It's the natural gas that's been noticed. Smell like gas, smell like. Whatever it is. But I also know that you guys ever been in a place that at first you're like, oh, it stinks in here, and then after a while. Or you know, everybody's house has a smell, but you don't notice the smell in your house. Really? Olfactory fatigue. I like this one. Let me taste something that might be HazMat. What's the safest of your five senses? Your sight. Sight. Okay. These are some of the signs and symptoms we might see in people. Changes in level of consciousness. They might be like salivating a lot, just copious amounts, or they might be really thirsty, have some problems with their vision, changes in their respiration, either breathing too slow, breathing too fast, got some pain, GI distress, changes in their skin, might be sluggish. Look at their pupils, are they bigger than normal, or are they constricted? Okay, so what are we gonna see in somebody who's been exposed?
All those changes.
Nausea, vomiting. LSD.
We'll get more into some of these, more like reactions to HazMat. We'll get into that in operations, but just be aware at an awareness level that if you see changes, we don't expect some of these eyeballs to be pinpoint. They're really big, or like you said, their breathing is off. And things like that, just be aware that that could mean they've been exposed. At awareness level, what's your role in monitoring and detecting? You don't. Well, here it says outside the scope of action. But we can be aware that there's a presence of HazMat. We can be aware of how much, like, big scope, little scope. All right, why is it outside of our scope?
The training.
What's that?
The training.
The training, yeah. It puts us too close and we don't have the training. Probably don't have the equipment. Leave it to the professionals. It's one. Woo! You guys survived.
One more chapter to go.
One more, and the next one. Shorter.